Welcome to the 12th session in our webinar series with the Alliance for Water Efficiency. WaterSense and AWE started this series in 2015. The goal was to reach the different audiences that have a role in ensuring outdoor water efficiency, including landscape professionals, local governments, and water utilities. We have had 11 successful webinars to date, many of which highlighted how local governments and the outdoor industry are working together to reach consumers. All of our webinars have been recorded and are available for on-demand viewing for people who are busy during the day when we hold the live session. Let's cover a few housekeeping topics before we get started. All attendees were muted when they entered the webinar to minimize background noise. To ask questions, you can type those in the chat box at the lower right-hand corner of your screen, and we will answer those questions at the end of the webinar. This presentation will be available on the WaterSense website and AWE's YouTube channel following the presentation. We'd also like to hear from you with a few polls. So first, who do we have on the call today? Local or state government, irrigation professionals, water utility, university or university extension services, or other? All right, looks like we have a good diverse array of people here today with the largest category of people in government. And our second question for the poll is, what part of the country are you calling from? West, Southwest, Midwest, Southeast, or Northeast? All right, looks like West has the highest representation. So today's webinar is Outdoor Water Use and Green Infrastructure. Our featured speakers are Mary Ann Dickinson, who is the President and CEO of AWE and the Executive Director of the California Water Efficiency Partnership. She has over 40 years of experience, having worked at the Metropolitan Water District of Southern California, the South Central Connecticut Regional Water Authority, and the Connecticut Department of Environmental Protection. She is a graduate of the University of Connecticut with a degree in environmental planning. Mary Ann has authored numerous publications on water conservation, land use planning, and natural resources management, and has co-produced 2 films which have been aired on public television and community cable stations. Julius Duncan is the environmental engineer for WaterSense outdoor programs. He works with the technical teams on new outdoor product specifications and coordinates with the professional certifying organizations to develop helpful resources to communicate with certified irrigation professionals. He has a master's degree in agricultural engineering from the University of Georgia and a bachelor's degree from Florida A&M University. Our last presenter is Stacy Erickson, Urban Watershed Revitalization Coordinator for EPA Region 8, who has been an employee of the Environmental Protection Agency for over 26 years. Currently, she works on sustainable development, green infrastructure, urban waters, and brownfields. She has previously worked in a number of programs at EPA, including enforcement, community-based environmental protection, Superfund, hazardous waste, and as a water quality technical advisor to the International Red River Board. Stacy spent 4 years on loan from EPA to the City and County of Denver as their brownfields coordinator. She also worked on water quality, sustainable development, and an affordable housing, green housing issues for the city as a part of Greenprint Denver. Prior to EPA, Stacy worked for 3 years for the Department of Energy at Rocky Flats on waste management and environmental remediation issues. Stacy is a Colorado native with a BS in Chemical Engineering from Colorado State University and an MS in Ecological Engineering from the Colorado School of Mines. She is also a graduate of Denver Community Leadership Forum and the Coaches Training Institute. I will now be handing over the slides to Marianne Dickinson, who will begin her presentation.
Thank you very much. It's a pleasure to be part of this webinar series. AWE is very happy to be partnering with WaterSense in this effort. And we're going to take the opportunity today, because the topic is green infrastructure, to talk about a program that we've developed that ties into the land use issues and helps support green infrastructure goals. So let's dive right in. Go to the next slide. The next slide here is a map that WaterSense has put together, which I think is really useful for this discussion, because it shows the percent growth in each of the states between the year 2000 and 2015, and then it also shows domestic water use in gallons per day per person. And as you can see by looking at the map, the states that seem to have the most population growth are often the states that often have the highest water use. So that leads into a situation where there's scarcity in some of those western and southwestern states in particular. As population grows, it creates stress as to how those water customers are going to be supplied as droughts intensify and as supplies get scarce. So next slide, please. So what's the answer to this? Well, one answer in a planning context can be the concept of water offsets. A water offset can allow growth to occur in a community that might be strapped for new supplies or drought-ridden without increasing the system-wide water consumption across the community or across the water supply service area. And it's a concept that's not really a new concept. We've applied offsets in air and wetlands and many other natural resource areas, but we haven't done a lot in water offsets. And what we're trying to do is promote this on an ongoing basis. It can be a combination, a development can be a combination of good on-site water efficiency and then an offsite that comes from off-site water efficiency, which can include offsets from green infrastructure. The point is to completely eliminate the impact of that new development on water supply, to keep the consumption in the community level and help avoid a building moratorium in a community, which is not ever a very politically popular situation to be in. As I mentioned, it's not a new concept, and even in water, we have seen that there are 13 communities around the country that have done offsets in various ways. Next slide. So what we decided to do at the Alliance for Water Efficiency was build a national template ordinance, a planning and zoning ordinance that could help communities who wanted to adopt on a voluntary basis a water offset strategy. So we built an ordinance tool, not just a straightforward model ordinance, but one that you can amend and adjust to the variety of settings that might be occurring in your community or your county or any regional area that might want to apply this. So we anticipate a number of different settings, different types of users, not just developer lawyers, but members of the community as well, and to help a community stay as water sustainable as they possibly can. Next slide. So the pieces of the ordinance are shown here on this slide. I won't go into any detail because I only have a few minutes, but we'll give you a link at the end for where you can go to take a look at all of this. But as you can see, it has all of the legal pieces of a typical planning and zoning ordinance. Next slide. But the big piece of this is the offset strategy, and we've developed a workbook that can help developers and planning and zoning commissioners select activities that can provide offsets when they're done off-site. And these include outdoor irrigation strategies that can be applied elsewhere. They can include green infrastructure strategies for rainwater and stormwater. They're all included in this strategy worksheet. Next slide. The sum total of what would be chosen would be selected to meet whatever the requirement would be in the ordinance. So as you can see in this offset table, this particular list of of strategies meets 100% of the potable new water demand of a development. And it doesn't mean a lot of different strategies. It can be actually a fairly inexpensive way for a developer to meet this requirement, and also a way for a community to fund its water efficiency program. Next slide. So to try to explain how this works, we developed 3 different examples that show how the ordinance can be applied and how the offset methodology can be applied. And the examples are all different so that you have a different range of types of development and types of governance structures. But I think all of the examples that we created show that the offsets are often not very onerous and can be a really good way for a community to accept economic growth without having to suffer water consequences. We've developed detailed user guides for both the ordinance and the methodology workbook. There's a picture there on the slide of the methodology workbook. And so all of this information is available free of charge. If you go to the next slide, we've posted it all on our Alliance for Water Efficiency website. We also have a separate URL for it, which I'll give you at the end, because eventually we want to build a standalone website for this program. But when you go to the website, you can request a package of materials be sent to you, and we offer at the Alliance also offer support. So the last slide is the slide that gives you information. It gives you my name and Bill Christensen's name, because we are the 2 staffers at the Alliance that support this activity. So you can just type in www.net-blue.org, or just go to our Alliance for Water Efficiency website. But we're happy to showcase this for you. I see there are a lot of local government folks on the webinar today, so please do feel free to get in touch with us. We'd be happy to be of service. Thank you.
All right, thanks, Marianne. Good afternoon, everyone. Today our webinar will go over the links between green infrastructure and how it can help reduce outdoor water use. Oftentimes, green infrastructure is installed with the goal of reducing runoff to prevent flooding, but it is sometimes forgotten that installing green infrastructure can also help increase water efficiency for residential and commercial landscapes. As many of you have probably experienced, water use for irrigation can be significant and can be one of the major culprits for water waste. Commercial facilities commonly have in-ground irrigation systems used to maintain an aesthetic landscape. While areas such as athletic fields may have specific requirements, other less used areas of the landscape may be able to incorporate green infrastructure. Climate can affect the amount of additional water needed to irrigate the landscape. While the amount of water required by plants is generally constant, the amount of rainfall and evapotranspiration in an area is often variable. The design and size of a landscape dictate the amount of water needed. Replacing some areas of the landscape with green infrastructure reduces the size of the landscape needing irrigation and can help keep water use under control. As much as 50% of the water residents use outdoors is wasted due to overwatering, poor irrigation design, improper system installation and management, lack of maintenance, and improper scheduling. When designing a landscape, keep in mind green infrastructure components that could reduce runoff and decrease the irrigated area. Installing WaterSense labeled spray sprinkler bodies can reduce outdoor water use, and weather-based irrigation controllers can properly schedule irrigation to avoid unnecessary watering. Weather-based irrigation controllers help reduce water use by scheduling irrigation for when it is necessary. WaterSense labeled controllers use data from local weather stations or rain gauges on site to start or cancel scheduled irrigation. Controllers can also be connected to other external devices such as soil moisture sensors or ET sensors for more accuracy. Spray sprinkler bodies are the part of the irrigation system that connects the sprinkler spray head to the water line. They work by maintaining a constant output pressure under varying conditions of incoming pressure. Proper pressure conditions reduce misting and overspraying from the emitters. The WaterSense WaterSmart Landscapes Guide was developed to help irrigation professionals identify water-efficient practices for residential landscapes. Our Best Management Practices Guide for commercial and institutional facilities, WaterSense at Work, has useful tips landscape managers can use to manage outdoor water use. Water-efficient practices included in the guide, such as xeriscaping, using native and low water use plants, and installing WaterSense products are great ways to save water. Additionally, installing green infrastructure such as rain gardens can be combined with native and low water use plants to increase water efficiency and decrease runoff. WaterSense has developed 2 new guides to help inform irrigation professionals and homeowners of the benefits of microirrigation. The first is a mini guide for irrigation professionals. It provides details of how to plan an irrigation system with microirrigation, tips for installation, and key things to look for when troubleshooting. The second is a guide for homeowners. It provides an overview of microirrigation for the do-it-yourselfer and considerations if they need to ask a professional. Green infrastructure is an alternative to moving stormwater away via conventional piped drainage and water treatment. It treats stormwater at the source by using vegetation, soils, and other practices to manage water. As communities grow and as water demand increases, water resources can get stressed. Incorporating green infrastructure into the design of the landscape can not only reduce runoff, but it can also save water to be used more efficiently. Rain barrels collect stormwater that would normally be directed towards storm drains. The water that is collected can later be used for irrigation, reducing the need to use water supplied by the city. Stormwater can also be redirected to a rain garden instead of the storm drain. Rain gardens are usually designed with the soil that is porous enough for water to naturally infiltrate quickly, and plants that can survive high water levels during storms. The plants should be native to the region, so they do not require more water than provided by rainfall. Because the rain garden uses plants that can survive based on local rainfall levels, the total area of the landscape requiring irrigation is reduced, and remaining irrigation water can be diverted to other uses. A major source of runoff during storms is from hardscapes such as roads, sidewalks, and rooftops. Green roofs reduce the area in the city devoted to hardscapes. Extensive green roofs are 2 to 6 inches deep and often do not need supplemental irrigation. Intensive green roofs are 6 inches and deeper. They can store a wider variety of plants, but usually require supplemental irrigation. Both types of green roofs can be used to divert rainwater into collection barrels and then used indoors or for irrigation. Whether you are building a green roof, a rain garden, or planter boxes, we encourage you to use native plants. A native plant is a species that is grown in the region without human introduction. In the U.S., each region has its own climate, topography, geographic features, and soil. This wide variety of features means there is no one-size-fits-all approach to selecting plants. Native plants have grown accustomed to the region and are more adapted to local weather patterns. For example, plants in western states can survive in the hot, arid environment with little to no rainfall for long stretches of time. Bringing those plants to the East Coast with cooler temperatures and higher rainfall would be out of their natural environment. Because native plants have developed based on their local environment, they are less likely to need supplemental irrigation, which will save you money. Native plants are more suited to local conditions and require less fertilizers and pesticides that could run off into lakes and rivers in the watershed. Next, we will have our featured speaker, Stacy Erickson from EPA Region 8 in Colorado.
Hi, everybody. As mentioned, I work in Denver, Colorado. EPA Region 8 covers some western states, Colorado, Utah, Montana, Wyoming, and North and South Dakota. So the photos that I'm going to be showing you are all from our region. The first photo that you see there on your slide is actually EPA Region 8's green roof in downtown Denver across from Union Station, and it uses sedums in a modular tray roof structure. It does require some supplemental irrigation. Next slide. A lot of partnerships that we work on within our region, and the folks that you see on here are the folks that work in a lot of our voluntary and partnership programs. We like to think of this as the kinder, gentler, less well-known side of EPA. And I think we're all serious in saying that I'm with the government and I'm here to help you, which a lot of times gets laughs from folks, but we really try to partner and work with a lot of our communities. So as you see on the slide, you can see the folks that work for our Region 8 office that work on a lot of different related partnership programs, including WaterSense. A lot of partnership programs that we work with across government agencies, including with HUD and DOT and FEMA. and the Army Corps of Engineers, just showing you, I think, the breadth of some of the things that we work on. A lot of these are incorporating sustainability and smart growth practices into affordable housing and hazard mitigation planning and long-term disaster recovery, which includes green infrastructure. Communities are facing a lot of different challenges, including trash, stormwater pollutants, flooding, drought conditions, and increasing growth that increases impervious cover and leads a lot of issues to be had with relation to stormwater. And one of the things I think that we really like to talk about is the fact that infrastructure that addresses multiple functions is less expensive in the long run, and is really the most cost-effective way to go to treat a multitude of issues. So essentially, when you increase the amount of impervious area in a watershed, you degrade streams. And typically at around 10% impervious cover, you start seeing impacts in over 30% impervious cover, which most of our urban areas are, you get some significant degradation. Green infrastructure can be really great for enhancing communities. It's multifunctional infrastructure. There's a lot of different ways to incorporate that. One of them is complete streets and green streets. And it's using streets for bikes, pedestrians, stormwater, as well as for cars. Green infrastructure is really about improving the approach to stormwater management. The traditional approach basically takes stormwater very quickly off of a particular site. That's what engineers have typically in the past have been what they've designed their infrastructure to do. As long as it got off quickly, that's what was important. I think as with the increasing levels of urbanization, you see a lot of impacts, and including what you see in the picture there. You get large amounts of stormwater in a really short time going into a water body that was never had that amount of stormwater or water in it in the past, and you get a lot of stream bank degradation.
Excess volume. Yeah, you're there. This is us really quick. Could you just let us know when to advance to the next slide?
I'm really sorry about that. So next, getting carried away there. Okay, there we go. Complete streets, and we're on the next slide now.
Great, thank you.
Okay, there we are. We're caught up. Sorry about that, everybody. So green infrastructure is really looking at stormwater as a resource, trying to manage the stormwater as much as possible on site, and trying to reduce pollutant loads that go into water bodies. And it's really a multifunctional infrastructure that's much more cost effective. Next slide. Low impact development is another term that's used a lot. It's basically looking at comprehensive land planning and trying to look at the pre-development hydrology of a site and trying to mimic that as much as possible. It can happen at multiple scales, whether you're conserving or protecting forests to be used for source water and drinking water, doing riparian protection or restoration, same with wetlands, or it can be sort of more of an urban focus. So green infrastructure actually works across multiple scales. It's a very sustainable stormwater practice. It can be applied to development, redevelopment, or retrofits. It tends to be less expensive if it's integrated on the front end. The picture that you see right there is actually Denver, Colorado. It's the old Stapleton Airport, which is where I live. This is actually a regional stormwater detention facility off of Interstate 70 behind Super Target and the Bass Pro Shop in the Northfield Shopping Center. It's actually a really lovely green infrastructure area. There's paths down there. There's benches, coyotes in there, foxes, a lot of bird life, and so it serves multiple functions. Next slide. As mentioned earlier, green infrastructure is really about trying to mimic natural processes, and that includes infiltrating, evapotranspirating, or reusing stormwater or runoff on site. It can be used at a lot of different landscape scales, as I mentioned earlier, and can be used for conservation efforts as well as restoration efforts. The photo that you see right there is Westerly Creek in Stapleton, Denver, where I live. This is actually a few blocks from my house. This stream was completely under taxiways and runways in a culvert under concrete and asphalt. It's been completely restored and daylighted, really good green infrastructure. I'll show you some other pictures later about what it looks like when it functions with a large amount of stormwater. Next slide. Green infrastructure builds resiliency for communities. It can save money. It recharges groundwater. Using cisterns and rain barrels reduces municipal water use. It helps reduce urban heat island effect and can help protect against storm surges. This is, for us, an interesting slide. Until 2016, rain barrels actually weren't legal in the state of Colorado, except under a very reduced circumstance, but they are now, which is really great that we can talk about it, encourage folks to use them. So green infrastructure is also really about systems thinking. For folks that are familiar with sustainability concepts and systems thinking, green infrastructure has a bigger impact when it's holistically integrated with other infrastructure. It's also multi-benefit infrastructure and is much more cost-effective. We like to say a lot that stormwater, we want to slow it down, spread it out, and soak it in. A lot of towns have used green infrastructure. It can be used in a lot of different practices and things that are already going on that folks already do. Things like parks, open space, urban forestry, parking lot landscaping requirements, climate adaptation strategies, resilience strategies, and flood restoration. The top photo that you see there is, again, Westerly Creek in Stapleton, Denver. That's actually during a large storm event. It functioned the way it was supposed to. There's actually quite a large floodplain area that's used for open space with some very expensive homes on either side of it. So the developers were able to get significant lot premiums by fronting onto this really nice open space. And it is great. No houses have been flooded in any of the storm events because they designed it really well. The bottom photo that you see there is a parking lot in Boulder, Colorado that uses landscaping and curb cuts to actually take the stormwater runoff from the parking lot and water the landscaping there. Next slide. A lot of different types of green infrastructure. There's a lot of terms that are sort of synonymous and similar, but green roofs, planter boxes, rain gardens, bioswales and bioretention cells, vegetated swales, tree trenches, ponds, porous pavements, green streets, wetlands and riparian areas, and rainwater harvesting. The photos that you see on this particular slide, the top one is the green roof for the Church of Jesus Christ of Latter-day Saints in Salt Lake City, Utah. It's a really lovely green roof with a lot of flowering plants on it. And the lower slide is actually Fort Carson, Colorado, which is an Army base here in Colorado. Next slide. Green infrastructure is really good for a lot of things besides stormwater management. I think I've mentioned some of these, but climate adaptation, reducing urban heat island, biodiversity, improving air quality, improving water quality, improving soil quality, and recreation and quality of life. The top photo that you see there is actually a development in the River North neighborhood of Denver. It's right along the banks of the South Platte River. It's a site called Taxi, former brownfield site that has done a lot of sustainable redevelopment. It's now become one of the hippest and coolest areas of Denver, but they actually, you wouldn't know that their stormwater is being managed by this. It looks like sort of really beautiful landscaping. And the bottom photo is, again, Fort Carson, Colorado, and that's a bioretention cell that has irises in it. Next slide. There's a lot of additional benefits to green infrastructure. Some of these have been mentioned already. so I won't go into them again, but reducing sewer overflow events. We don't have hardly any combined sewers in our EPA region, but a lot of places east of the Mississippi and also on the West Coast actually do have combined sewer overflows. And so green infrastructure is a great complement to the gray infrastructure. There's increased carbon sequestration, reduced energy demands on buildings, improved human health, increasing land values. Permeable pavements tend to have less splashing, spraying, ponding, and noise, and also fewer pollutants coming off of them. It tends to be much more aesthetically pleasing, and it really is a community amenity, and it makes communities more resilient. Next slide. I'm not going to go into these great detail. A lot of these are more for your reference later on for some of these websites. But there's been a lot of discussion about the cost of green versus gray infrastructure. And particularly when you look at long-term, green can be less expensive. Retrofits tend to make it a little bit more expensive. The photo that you see there is actually Denver Housing Authority. It's the affordable housing developer for Denver. That is their Park Avenue redevelopment. And because it's fairly urban, they were having to put in stormwater vaults at a cost of typically around here, a few years ago, stormwater vaults were around $750,000 to $1 million. By using green infrastructure, they were able to reduce the cost of that. And EPA's Region 8 building actually has a smaller stormwater vault because we have a green roof on top of our building, and they were able to size it much smaller. Stormwater vaults are used in a lot of very urban redevelopment where real estate is quite expensive. They're not much of an amenity. Ours is in our parking garage. It's not anything particularly great to look at, but something that has to be done to manage stormwater. Next slide. A lot of different ways to get to green infrastructure, including regional stormwater planning, stormwater ordinances, zoning and building codes, looking at shared parking, if there are development requirements for volume reduction, which some places have, minimizing street setbacks, bioretention requirements, urban tree canopy, riparian setbacks, looking at street width and parking lot requirements can help you get to green infrastructure, and then changing water and stormwater pricing structures in order to incentivize the use of green infrastructure. Next slide. Green infrastructure in the semi-arid West is a little bit different. This is always interesting for me. I work with a lot of folks on the East Coast, but in a semi-arid or arid climate, there's quite a bit of difference. Denver has 15 inches of precipitation a year, over 300 days of sunshine, and there's a lot of infrequent but very intense storms. And so xeriscaping low water native plants is really important. Sometimes it doesn't always look as green as it does in other places like Portland, Seattle, or the East Coast. So sometimes we call it taupe infrastructure or brown infrastructure out here. And the photo that you see there is a sod roof in Jackson, Wyoming. And sod roofs are widely used in Norway and are a type of green roof. Next slide. So in the semi-arid West, as I mentioned, we don't have a lot of combined sewer overflows, so we don't have the ability to use consent decrees to compel people to use green infrastructure. So our uses of green infrastructure in our EPA region are all about voluntary approaches. Also, Western water law is quite a bit different than Eastern water law, so prior appropriation means that someone else downstream may own that water. We also have a lot of clay soils, which can impede infiltration. So it's really important to design and engineer for infiltration. And so site-specific design and installation is really important. In irrigation is really important to get plants established. It typically can take 3 to 4 years of irrigation in order to get drought tolerant and native plants established in this region. The photo that you see there on the bottom is the former Museum of Contemporary Art in Denver, and so that's sort of green infrastructure as an art form. Next slide. Number of barriers to green infrastructure in the semi-arid West. There's been a lot of discussion around design, construction, and maintenance costs. A lot of different mixed messages from different government agencies and departments. Typically, public works departments tend to control stormwater. Parks departments tend to manage more green infrastructure and open space. There can be a misperception on the economics of green infrastructure. Not doing regional and site planning can make it difficult to incorporate at the tail end. Sometimes it's just difficult to get people to trust something new if they haven't done it before. And then again, the irrigation can be an issue because you do need to get the plants established, and so you need to install irrigation infrastructure, which costs money on the front end. So the top photo that you see is Stapleton, Denver again. Those are street medians with running paths. And then the bottom photo is, it's not the best photo that I have because it doesn't show a lot of it was taken early on before the infrastructure was very established, but that's Odell Brewery in Fort Collins, Colorado, with curb cuts in there to use stormwater to irrigate a lot of the plants. Next slide. These are just a lot of websites and tools. EPA Region 8 has a green infrastructure website. It needs to be updated, but we have a lot of good examples and links on there. We partner a lot with Urban Drainage and Flood Control District, which is located here in the Denver metro area, and a lot of our states and local governments actually use Urban Drainage's Volume 3 Criteria Manual that has a lot of green infrastructure practices in it. And that's going to be updated soon, and it's going to include the next link, which is the Denver Ultra-Urban Green Infrastructure Guidelines, and I'll talk more about that a little bit later. I won't go into some of the other ones there, but they're available for you to look at later. The photos that you see, the top photo is the South Platte River right near downtown, and the bottom photo is the other side of the river with permeable pavements that's right near REI and Shoemaker Plaza. Next slide. Just wanted to put a brief plug in for EPA's Green Infrastructure Wizard, or GWiz tool. We have a lot of things on our EPA websites about green infrastructure, costs, design, barriers, etc. The Green Infrastructure Wizard makes it a little bit easier to find some of those things, and it's a little more intuitive to use, and so I highly recommend using it. It's a pretty cool and fun tool. EPA has some funding sources that can be used in some cases for either design or installation of green infrastructure. Our funding sources are pretty limited, so I'm not going to go into a lot of discussion around this, but these are just some possible things that we've used in our region to try to get green infrastructure projects moving. Next slide. These are photos of Weir Gulch at the Sun Valley Affordable Homes in Denver, Colorado. This is one of our Partnership for Sustainable Community sites. The top left photo you see is Weir Gulch. It was actually a concrete channel. It was pretty ugly. It was pretty dangerous for the people and the families that were living nearby there. It was actually, the concrete was pulled out, and it was pretty amazing in the transformation. They hadn't even finished the construction. They still had bulldozers out there, but when they pulled out the concrete, we had deer in there, we had some crawdads, and we had a turtle before construction was even complete. The top right, you can see this is as the vegetation was starting to get established. And then Weir Gulch flows into the South Platte River, and they put in a number of drop structures and other things in order to decrease sediment loading to the South Platte River there. And this is going to be a huge sustainable redevelopment along the banks of the South Platte River, and it is going to be an eco district that Denver Housing Authority is working on the redevelopment. It's got a huge amount of new significant infrastructure that needs to be installed there. Next slide. This is Johnson Habitat Park. In addition to the slides that I just showed you, all of this was part of Denver's and the Greenway Foundation's Greenway Master Plans and what they called their River Vision Implementation Plan. These were 2 of the first 5 projects. So this is actually a regional park along the South Platte River, which EPA did a little bit of assistance in here and trying to use it in addition to being a park, but using it for stormwater. Next slide. This was a conceptual green infrastructure design done for the Urban Land Conservancy. It was actually done as part of a design charrette at a Housing Colorado event, and it was done with students. The photo that you see on there was actually the Park Avenue development for Denver Housing Authority that I mentioned earlier, but it used some similar concepts. Next slide. This is basically analyzing the site and trying to look at how you would incorporate green infrastructure into the site. They actually looked at what would happen if they were able to acquire a couple of other pieces of property. The great thing about this design was that it could actually infiltrate all of the stormwater on site in sort of normal storm events. Next slide. Just a few things and photos from that document that show different toolbox examples for green infrastructure. Next slide. These next 2 slides are essentially trying to show how it's really important to engineer and design the infiltration correctly and make sure the soils and everything can do the things that you're supposed to do so that you know how much stormwater each of those practices can manage. Next slide. Again, this gives you some ideas of how much stormwater each of these different practices can actually infiltrate. Next slide. One of the things about green infrastructure that's a little bit different than gray is operations and maintenance considerations. So monitoring the infiltration and drainage, doing pruning and mowing, mulching. Sometimes you have to do mulch removal because in storm events, mulch may move from one location to another. Watering and fertilizing, replacing dead plants, looking at inlet, outlet, and under drains if those exist within the green infrastructure. And all of these things are done at different frequencies. The photo that you see there is again Stapleton, Colorado. It's in Denver, Colorado. It's Greenway Park. It has a large bioswale that actually runs behind it. It took 3 years of irrigation to establish these plants. This is actually a picture in the fall, but currently irrigation is not used on that. They are able to use just stormwater runoff from the grassed areas and from the surrounding homes as a way to water this green infrastructure. Next slide. This is an ultra-urban green infrastructure guideline manual that was done in partnership with the City of Denver and Urban Drainage and a number of contractors. Denver realized that they were wanting to promote more green infrastructure from developers, but some of their ordinances made that a little bit difficult, and so developers were having to get variances and having to go through a fairly long planning process in order to be able to do that. And so Denver came out with these green infrastructure guidelines, which basically are sort of off-the-shelf green infrastructure that developers can use to manage stormwater. It also contains a lot of maintenance checklists, and this will be added to Urban Drainage's Volume 3 criteria manual in the next upcoming version that's coming out. Next slide. This was a study that was done at Sun Valley, which I mentioned to you all earlier. This was done with some EPA brownfields land revitalization funding. And basically, it's looking at 4 different stormwater options to manage stormwater for the same site. One option is looking at conventional conveyance, one with green infrastructure with some centralized retention. One was a green infrastructure with decentralized retention, including some blue roofs. And then we added a fourth option, which we ended up calling option 2.5, which was integrated ultra-urban green infrastructure using the manual that I previously mentioned and using some off-site detention and water quality. The really interesting thing about this is typically this isn't done that, you know, somebody can evaluate all these different options for managing stormwater. But what happened on this one is that it had the second lowest capital costs, and it had the least expensive annual operating cost and the least expensive 20-year total net present value costs. So it really shows that green infrastructure can be incredibly cost effective. And the option 2.5 also incorporated a lot of the green infrastructure on what they called podium tops and green terrace courtyards. And these were lower than the surrounding housing. And so a lot of the other tops of the buildings were being used for solar photovoltaic electrical production, but the lower roofs, because they were shaded, didn't work very well for solar PV, but they were ideal candidates to put green infrastructure on. Next slide. And that was it for my prepared slides. And I think we're moving to questions next.
Yes, thanks, Stacy, for that presentation. Your slides were helpful in showing how stormwater planning and building codes are some of the ways cities can approach including green infrastructure in their planning. Irrigation professionals that are looking to include green infrastructure in their landscape can look to some of these examples, and we'll provide a copy of the presentation to access the links for ways they can include rainwater harvesting and rain gardens in their landscape. As you're taking time to type in your questions to the chat box, we'd like to put up a few quick poll questions. After we take questions from today's speakers, we'll have a few more slides to close out the session and ask one more poll question about topics for future webinars.
What types of landscapes do you work with? Residential only, commercial only, both residential and commercial? And it looks like the vast majority of our attendees work with both residential and commercial landscapes. Our second poll question is, do you need a way to note your attendance of this webinar? If so, we can send an email to attendees who joined for at least 30 minutes with proof of attendance. All right, thanks for your responses. We are going to go ahead and go to some of the questions that came in during the presentation. The first is, what do you think the biggest challenge is with implementing a net blue method? And
that sounds like that's a question for me.
Yes.
So one of the biggest challenges that we see in adopting a water offset is that the developer community doesn't often understand how this actually enhances their ability to get development approved. So there needs to be a lot of community discussion about this in advance. I offer an example of the city of Santa Monica that held a lot of outreach meetings with its constituent stakeholders before they adopted their own water offset ordinance. So I think it needs a lot of community discussion in order to get a lot of misconceptions ironed out. I think another barrier that communities need to work through is just how they want to customize it. There are plenty of ways to make a net blue water neutral development ordinance customized for certain types of developments, certain amounts of increases in potable water use. The amount of the offset doesn't have to be 1-to-1. If it's a really scarce community, they can change that ratio to 1.5-to-1. We give an example of how that could occur. But I think a lot of this would be easier to adopt at the local level once discussion starts, and there needs to be stakeholder discussions before anything is officially proposed.
It looks like the next question is for Stacy, asking, have you done quantification research on these benefits of GI?
EPA has done quite a bit of research on the benefits, and a lot of that can be found on our website and on the Green Infrastructure Wizard tool.
Next question is, what challenges have you all seen in proper maintenance of GI installations? What additional training would be needed for stormwater or landscaping of park crews?
This is Stacy. I guess I can start off with an answer to that. I think that there's always some challenges in dealing with maintenance. You know, it depends a lot on the design to begin with, and if the design was done well and had you know, the appropriate amount of installation and had good plant selection. I think, as Julius mentioned, you need to have plants that can, at least for a while, stand to be a little bit wet and then dry out. So that's really important. Sometimes if you don't design the infiltration right, you can have ponding. And actually in Colorado, you're not allowed to detain the water for more than 72 hours. So it's really important that you don't have water sitting there, because it actually doesn't belong to you. So it's real important to make sure that that happens. But, you know, the maintenance is really important. And I think a lot of times, you know, people tend to put in green infrastructure and then maybe don't follow the maintenance. I think that a lot of cities have actually created databases and, you know, in operation and maintenance checklists, and then trying to make sure that all of the different best management practices are actually serviced on the right time frames. That's really important.
This is Mary Ann. I completely agree with that, and it's especially critical if green infrastructure projects are done on private property. On public land, presumably there would be the opportunity for regular oversight, but sometimes when the projects are done on private property, they are not often maintained as they should be, and thus don't provide the benefits that the design was intended to. So there does need to be, I think, a training of whoever it is that's going to be maintaining that landscape in the long run.
All right. And next question, Stacy mentioned needing irrigation for 3 to 4 years to establish new plantings. After 3 to 4 years, do you decommission the irrigation, or is it still to some extent in July, August, particularly for areas with insignificant summer precipitation?
It really depends a lot on the design. So I think, as I mentioned, one of the areas there, Greenway Park in Stapleton, that one actually, the irrigation lines are still running. I mean, are still there if they needed to use them, but they typically haven't used them. It depends a lot on plant selection and how hot and dry it may be. So, for example, like EPA's green roof, because it's a modular roof, requires irrigation, but typically in July or August a little bit more than at other times of year. So it really depends on how it was designed. Greenway Park was designed so that it got a lot of stormwater runoff from turf areas and surrounding houses, and since people water their lawns, you know, a lot of that then runoff went there and kept that vegetation, fairly moist you know, when it was pretty hot and dry.
Yeah.
All right, and we have two more questions. The first of those is, if you are a contractor or landscape designer, at what point does an engineer need to be involved in designing these GI systems? And Stacy, that's for you.
Sure, that's a great question. My experience has been that both the engineer and the landscape architecture piece need to work really closely together. I am an engineer, but I have found that the projects that were led by landscape architects probably turned out a little bit better, and I think that was more because the landscape architects that we had worked with incorporated the engineering and the plants up front. I think in some cases, if you just do an engineering design and then you just let somebody, you know, select a couple plants that you're going to plop down at the end, that you don't get the same kind of a product in the end, and also, you know, particularly because, you know, you aren't just looking at stormwater, you're looking at the plants, and you're also looking at creating a community amenity. So having the two work together from the beginning, I think really works the best.
All right, and we'll have one more question. Any questions that we didn't get to now, we will go ahead and answer by email after this. So the last question is, what is the most challenging part of maintaining GI?
I guess this is Stacy. I guess I'll give that one a shot. It can depend a lot, you know, on climate, but, you know, plants can be temperamental. A lot of times, even when you design things correctly, things don't always work out the way you thought, or just plants don't survive the transition period. And then obviously maintenance is important. I know where I live at Stapleton, we have some small turf areas, but we have a lot of landscaping that uses irrigation, and the irrigation needs to be maintained appropriately. But also, I think, you know, the people who maintain it are incredibly important, and having them properly trained. My HOA had problems. We had people that were more used to managing turf grass and didn't really know a lot about plants, and we lost a lot of plants as a result. And so they ended up bringing in different contractor, and then also having somebody that was very focused on the trees, and having then a third person that was very focused on the other plants. And I have to say that, you know, this year I've lived there for 12 years. Our landscaping looks the most amazing because we had people who really knew what they were doing and knew a lot about plants.
All right, again, thanks, Stacy, for those answers. And I'd like to remind everyone that microirrigation is also a valuable resource for maintaining local plants, especially ones that do not require as much irrigation and do not necessarily require overhead irrigation. And WaterSense does have 2 new guides for microirrigation for both homeowners as well as irrigation professionals. Some of you may already be WaterSense partners, but we might be new to others. Our program depends on our partners to carry the message of water efficiency to consumers. These are the categories of partners that we have. Many of the utility and government organizations on the call today fall into our promotional partner category. I want to encourage you to become a WaterSense partner. After all, it's free, and we have a lot of material to help you communicate water efficiency. And finally, our last poll question. Hopefully you are finding these webinars to be beneficial. We'd like your input on potential topics for future webinars. What webinar topics are you interested in for the future? Consumer-focused irrigation auditing, cloud-based solutions to irrigation, benefits of microirrigation to landscapes, improvements and water-saving features of turf grass. Thanks everyone for your responses. Looks like a lot of people are split between the micro-irrigation for landscapes or turf grass. And so we will be looking to add these to our webinar selections in the future. And for anyone looking for any of our past webinars or any future resources, please visit epa.gov/watersense for all of the information we have. And lastly, I'd like to thank our speakers, Mary Ann Dickinson and Stacy Erickson, for your presentations today. And thank you to everyone that has joined our webinar. Have a great day.